in our class right now. The recording has been started and let me go into the full screen mode. Capacitance. Okay. So let us, for the first, we will note down all the formulae. So this is a structure for a cylindrical capacitor and this is a structure for a spherical capacitor. We will require these two diagrams for understanding the numerical. कि भाई इनर सिलेंडर है तो उसका रेडियस ए है, आउटर सिलेंडर है तो उसका रेडियस बी है. सेम गोज विद द स्फेरिकल कैपेसिटर. इनर सिलेंडर ए है, इंटरमीडिएट सरफेस जो अज्यूम किया था वो R1 है, एंड बी समटाइम्स अकॉर्डिंग टू द given data sometimes it may be infinity or it may be some finite value. Okay, so we will list out all the formulae. So in general we can say that okay, C is equal to Q upon V, or in generally we say that Q is equal to CV. Just we are putting it down, putting it in terms of capacitance. Then about parallel plate capacitor, we have C is equal to epsilon A upon D, and if we do have some kind of series structure in parallel plate capacitor, means we do have two parallel plates. Okay, and we have some difference. यहाँ पे एक dielectric material है and यहाँ पे दूसरा dielectric material है. Let us say its permittivity is epsilon 1 and its permittivity is epsilon 2. So we do have one capacitor and we do have another capacitor. So two capacitances are in series, so their equivalent capacitance can be found in this way. Then we have energy stored in a capacitor, which is expressed as W is equal to 1/2 CV square, where V can be expressed as minus integral of E bar dot dl bar, and E can be expressed as Q upon 4 pi epsilon 0 R square A R cap. Then going to the coaxial cable capacitor or cylindrical capacitor, we do have an expression C is equal to 2 pi epsilon 0 L ln of B upon A. यहाँ पे epsilon 0 लिखा है क्योंकि we have assumed permittivity of the dielectric material is epsilon 0. Air is used as a dielectric material. If we do have some different kind of material, we have to add epsilon R, relative permittivity of that material. Then about spherical capacitor, we do have two capacitances. Okay, C1 is equal to something and C2 is equal to something. In this expression, we have assumed that B tends to infinity. Okay, B tends to infinity. यहाँ पे देखो ये जो इतना जो डाइलेक्ट्रिक है that is epsilon 2 and the next part of the dielectric material is epsilon 0. So same has been reflected in these formulae. Okay, so having list of these formulae with us, we can solve the numerical. Let us go with the first numerical. Calculate capacitance of parallel plate capacitor. Okay, parallel plate capacitor दिया है मतलब C is equal to epsilon A upon D. Having mica dielectric with relative permittivity of 6, area is equal to 10 inch square, and separation is equal to 0.01 inch. So all the dimensions are given into inches and we have to convert it into meters. Okay, so we have epsilon C is equal to epsilon A upon D. A is given, epsilon is epsilon 0, epsilon R. This epsilon will be epsilon 0, epsilon R, and D is given. So we do have all the quantities. Only one thing we have to manipulate is converting inches into the meters. So you write down like 0.0254 meter, or you can write down 2.54 into 10 raised to minus 2. Choice is yours, and all the quantities are known. We need to calculate only C. So this is a kind of straightforward numerical. Only the change is instead of giving the dimension in meter, we have the dimension in inches. Okay. So now moving on to next numerical, find the relative permittivity of dielectric material present in parallel plate capacitor. Once again, we have the parallel plate capacitor. First case and second case. Okay, two cases are there. In first case, we are given with area. We are given with separation or distance between the two plates. We are given with applied voltage and we are given with energy stored. Okay. In second case, we have electric field rho s. यहाँ पे थोड़ा सा point है, अगर पता है तो ही solve कर पाएंगे, and we have the separation. Okay, so two cases, two different cases. Let us go with the first case, part 1. So we are given with a value of WE, energy stored, which is expressed as W is equal to 1/2 CV square. Okay, यहाँ पे WE दिया हुआ है, V दिया हुआ है, we need to calculate C. C is expressed for parallel plate capacitor as epsilon A upon D, epsilon nothing but epsilon 0 epsilon r. Epsilon 0 is a known quantity, epsilon r दिया हुआ है क्या, that is to be calculated. Find relative permittivity of dielectric material. तो epsilon r find करना है. A दिया हुआ है, D दिया हुआ है. Okay, so we do have two unknowns over here, C and epsilon r. So let us put this expression in the above. So we can write down W is equal to 1 half epsilon 0 epsilon r A upon d v square. So in this expression only epsilon r is unknown because We दिया हुआ है आपको न्यूमेरिकल में 1 माइक्रो जूल. तो सारी quantities known quantities है, only the epsilon r quantity is unknown and that is what we need to find. So you can use the equal to sign on your calculator. I don't know how to show you how to solve an equation on a calculator. Okay, probably in next lecture I will arrange some camera setup and will show you how we can solve this kind of equation directly. Okay, then going for the next part where E is given, rho is given, and D is given. So let us see. So D is nothing but, okay, the electric flux density in case of parallel plate capacitor is nothing but surface charge density, and which is expressed as epsilon E, and epsilon is nothing but epsilon 0 epsilon r. So we can write down, oh, sorry. So we can write down, okay, so rho s hai, epsilon 0 we know, E is given to us. So we can write down epsilon r is equal to rho s upon epsilon 0 E. So doing the calculation, we will have the epsilon r. So I will wait for 1 minute. It's 9:16. I will wait for 1 minute. Please note down the steps included in the numerical. Please note it down quickly. Whenever I say note it down, that doesn't mean you are going to take a screenshot. Is there anyone who took a screenshot? Okay, great. No one has taken. Is there anyone who didn't wrote the steps inside the numerical? Okay. Have everyone noted down the steps? Still no response.
झालं सर.
Yes, sir.
Okay, okay, great.
डन सर, डन सर.
Okay, okay. Okay. So moving on to next numerical, determine capacitance of a conducting sphere. Okay, now we have a different geometry, spherical capacitor of radius 2.5 millimeter covered with polythene layer, epsilon r is equal to 2.25 and 2 millimeter thick. Okay, तो spherical capacitor है, capacitance find करना है, and we are given with radius means a and epsilon r and the distance क्या कहते हैं उसको, thickness of the material, dielectric material. So capacitance C1 due to epsilon r. Okay, what we need to do, what we need to find the capacitance of the conducting sphere. तो आपको एक स्पीयर दिया हुआ है विथ रेडियस a, इसके ऊपर एक पॉलीथीन डाइलेक्ट्रिक मीडियम का लेयर है और इसका विड्थ दिया है 2 मिलीमीटर और इसका इप्सिलॉन आर रिलेटिव परमिटिविटी दिया हुआ है 2.26. सो वी कैन से दैट कि भाई जो भी कंस्ट्रक्शन, जो भी ज्योमेट्री यहाँ पे फॉर्म हो रही है, वन मोमेंट प्लीज. एक्सट्रीमली सॉरी। सो यहाँ पे जो भी ज्योमेट्री फॉर्म हो रही है, सो वी डू हैव one capacitance due to this epsilon r, okay, and there will be another capacitor, with b equal to infinity, and that will be with a relative permittivity of epsilon 0. So it is find the capacitance C1 due to epsilon r, given epsilon r. Okay, so we do have some formula in our notes that C1 can be expressed for this kind of geometry as 4 pi epsilon 0 epsilon r 1 upon a 1 upon r1. Okay, so if a is equal to how much, 2.5 millimeter, so what will be the r1? R1 will be 2.5 plus 2 because thickness कितना दिया हुआ है 2 millimeter, that will be 4.5 millimeter. So you do have all the quantities and you will get a value of C1. Okay, first part. Then capacitance C2 due to epsilon 0 by considering outer sphere at infinity. तो उसके लिए अपने पास फॉर्मूला C2 is equal to 4 pi epsilon 0 R1. Okay, R1 क्या था 4.5 millimeter. We will have the value of C2. Now we are going to find a total capacitance, that is 1 upon C is equal to 1 upon C1 plus 1 upon C2. तो इसकी वैल्यू और इसकी वैल्यू, put the two values in this expression, we will get the value of total capacitance. Okay, capacitance आपको मिल जाएगा. Every time put your क्या कहते हैं उसको, unit in terms of Faraday. Okay, microfarad or picofarad जो भी आएगा. Okay, let us have 1 minute and note it down in your notebook. I do have a timer at my end, so I keep on looking towards the timer so that I won't miss the timing and you will have sufficient time, lot of time. So if you have observed, the numerical are straightforward as long as you know the formulae. Okay, you know the formulae and you know the cause of the formulae. क्योंकि यहाँ पे ये formula true है because of this assumption, infinity, b is at infinity.
सर एव्हरी टाइम आउटर स्पेअर जो असेल तो इन्फिनिटीच कन्सिडर करायचं का?
हो. आणि जर तुम्हाला b ची व्हॅल्यू इन्फिनिटी दिलेली नसेल तो यू रियली गो बैक टू योर डेरिवेशन जहां पे हमने b इक्वल टू इन्फिनिटी रखा था. लेट मी show that part of derivation to you. Sorry, कहाँ पे है derivation? Let me stop sharing and let me share the text of window. ओके, कहाँ पे है? यहाँ पे. ओके, तो यहाँ पे देखिए ये वाली स्लाइड दिख रही है ना अभी, ब्लू ब्लू बहुत सारा. ओके. Let me have some different color. ब्लैक रेड ही लेता हूँ. यहाँ पे देखिए, यहाँ पे इंफिनिटी रखा था विथ अवर assumption b is an infinity. अगर यहाँ पे b रखता हूँ मैं, ओके, सो व्हाट आई विल हैव, जस्ट लाइक यहाँ पे r1 है और यहाँ पे a है, यहाँ पे b है और r1 है. So similarly we can write down यहाँ पे क्या मिला, a and r1. So we will have 1 minus r1 minus 1 upon b. ऐसे आएगा. This will be the change. That's it. But since our assumption was infinity, ये 1 upon b ये हो गया 0 and we are left with with a term 1 upon r1 only. सिर्फ इतना ही change आएगा. Okay, but looking at your examination pattern, we are going to consider b 0.99% at infinity. Okay, but still this is the understanding of the derivation. Your b कहाँ पे vanish हुआ था. Okay, now let us go back to our numerical part. And where is it? Okay, here is it. Now all the numerical were straightforward and put the formula and get the answer kind of numerical. Now let us increase difficulty level. Once again we are looking at a sphere. Okay, so conducting sphere of radius 5 centimeter has total charge 1 microcoulomb. Okay, A is given here, Q is given. The sphere is surrounded by inhomogeneous sphere. Okay, इतने रीजन में 5 से आगे 10 सेंटीमीटर में in which relative permittivity varies like this. तो एक स्फीयर है with radius 5 सेंटीमीटर, 5 से 10 सेंटीमीटर तक. ओके, 5 से लेके 10 सेंटीमीटर तक, मतलब ये 15 सेंटीमीटर. Okay, so we do have here permittivity, this time not a single value but expressed as 1.1 upon r. Okay, so this is the understanding of the numerical. Calculate the potential difference and capacitance. Let us see कि ये potential difference को क्यों जरूरी है और capacitance को कैसे find करना है. Okay, we really don't have much क्या कहते हैं quantities expressed over here. So let us go with the formulae, set of formulae. So we are given with 5 is equal to, sorry, a is equal to 5 and uh, this b has to be 15, I guess 15 centimeters. Okay, and we will have kind of single capacitor over here, and we are given with q is equal to 1 microcoulomb. Epsilon is expressed as epsilon 0 epsilon r, and v is expressed as q upon v. Q, anyways, we need to find a potential difference. Okay, how to find it? We have an expression for v, only one expression for v is, that is minus integral of e bar dot dl bar. So we need to have e bar as well as we need to have dl bar. Okay, and we need to find the value of e bar and we need to find the value of dl bar. And from our understanding, whenever we do have cylindrical and spherical capacitors and geometries, dl bar is dr ar cap, because we always move along the radial direction. Okay, and E is expressed as q upon 4 pi epsilon 0 r square ar cap. Now do remember that r square, okay, we are going to have क्या कहते हैं उसको 1 upon r square integration. Okay, let me write it down over here by putting the values of e bar. Okay, I will write down q upon 4 pi epsilon, let us say epsilon. Okay, epsilon square ar cap dot dr ar cap. Okay, so what we will have, minus, take out the constants from the integral 4 pi. Okay, epsilon is given as, we do have epsilon r as well. Okay, uh, let me write down that too. dr is equal to epsilon 0 epsilon r square. Okay, इस epsilon 0 को मैं बाहर ले लेता हूँ. Okay, so we will have epsilon 0 which is outside the integral. We are left with epsilon r, and which is expressed as 0.1 upon r. So क्या हो गया भाई, सिलेक्ट हो जा. So instead of epsilon r, what I will write down, okay, 0.1 upon r. We are substituting the value of epsilon r. So r and 1 r gets cancelled out and this 0.1 comes outside the integral term. So we will have minus q upon, ये 0.1 अगर बाहर निकालता हूँ, 0.4 pi epsilon dr upon r. ये जो रिलेटिव परमिटिविटी था, रिलेटिव परमिटिविटी, ओके, तो कौन से रीजन में है? इस रीजन में है. वी डू हैव डाइलेक्ट्रिक मटेरियल इन दिस रीजन, डू रिमेंबर दैट. फ्रॉम 5 to 10, फ्रॉम 5 to 10, तो r कहां से हो रहा है 5 to 10, and while putting the values, while putting the limits of the integral, we always go from outside to inside. तो outside sphere में r is equal to 10 and inside sphere में r is equal to 5. So integral limits become 10 centimeter, let us say then 0.1 meter to 5 centimeter. So let us say 0.05 meter. We want to put it everything in terms of meters. And now you are going to solve this इंटीग्रल. ओके, तो यहां से आपको v की वैल्यू मिल गई. पुट दिस v वैल्यू इन दिस एक्सप्रेशन. ओके, सो q अपॉन v, q तो दिया हुआ है आपको, so q upon v we will have the capacitance. So there is a little bit mathematical steps involved in solving the integral. Epsilon is equal to epsilon 0 epsilon r, but epsilon r itself is expressed as 0.1 upon r. So we have to manipulate with the constant terms, and we will left with this final step to be evaluated. Okay. So let us have 1 minute more to note down the steps. But still, if you look at the numerical, it is a straightforward numerical as long as we know the formulae. Every time I am stressing on the formulae, okay? Proof जो आते हैं, those are for subjective examination, and जो फार्मूली है वो आपके एमसीक्यू के लिए बहुत ज्यादा इंपॉर्टेंट है. ओके, लेट मी अनाउंस फ्यू थिंग्स. वेयर इज माय नोटबुक? ओके, while you note down the things, let me announce few things over here. ओके, सबका लिख के हो गया?
Yes, sir.
Okay, okay. So about your semester, let us have some dates and timings. Your term end will be on 11th of November. Okay, term end is on 11th of November. Before that, you have to complete your journals and assignments and everything. Uh, on 24th October, on 31st October and 1st November, you will have your unit test 2 on unit number 3 and 4. For electromagnetics, probably it will be on unit number 2 and 3. Okay, I repeat the dates for unit test 2. It will be on 24th of October, 31st of October and 1st of November. Okay, the schedule will be displayed soon. You are going to have subjective tests just the way we did for unit test 1. We are going to have unit test 2. Float the question paper, you write the answers and upload those answers. But this time, no extension in timing will be given. Okay, no extension. Last time पूरा दिन भर आपका चल रहा था कि मुझे अपलोड करना है. It is not going to happen. So if we have an exam from 10 to 11, you will have 1 hour to upload your work. Okay, 11 to 12. Then if you have lab manuals, there are two approaches. Some of the faculties will give you lab manual in a printed form. They will ask you to take the soft copy and add your material or add your simulation results into those. That is a screenshot of your work. And some of the faculties may ask you to write down on the journal pages. So you do have two approaches. Okay. So first approach, if soft copy of the manual is given and you are asked to put only the screenshots of your work, in that case, you will take the printout and you will take the photograph of your printout. Printout पे क्या क्या होगा आपके, आपका नाम वगैरह भी है ना, रोल नंबर वगैरह भी है, वो पूरा लिख के you will take the snapshot and you will upload that snapshot. You are not going to upload the soft copy of that material, so that at our end we will be confirmed कि अच्छा आपने प्रिंट आउट निकाल ली है। क्यों जरूरी है वो भी बताता हूँ। About write up, okay, fine. You are going to write down on the journal pages, any kind of journal pages, okay, and you will take the screenshot, sorry, snapshot, and you will upload that in the image or PDF format. तो ये करना जरूरी क्यों है? Because before 11th of November, we want your file to be ready. कॉलेज की फाइल नहीं है आपके पास, कोई दिक्कत नहीं है, बट ऑन 11th ऑफ नवंबर यू विल हैव योर ओन प्रिंट आउट्स एंड एवरीथिंग अलोंग विथ यू। ओके, सो 11th ऑफ नवंबर के बाद आपको फिर से उस लूप में जाने की जरूरत नहीं है। वंस इज डन फिनिश, प्रिंट आउट निकाल के लिख के पूरा मस्त फाइल में लगा के साइड में रख दो, एंड वेन एवर इट विल बी आस्क्ड फॉर द सबमिशन वी विल डू accordingly. We really don't know what will be the guidelines regarding submission of your journals. We will see and we will decide it later on. Okay. Assignment completion has to be done before 11th of November. Okay. And on in this week, your parents are going to call regarding your attendance. Okay. Uh, for third year, it is a cutoff of 75%. जिनका attendance 75% से below है, they will have their parents क्या कहते हैं information about it. कॉल जाएगा कॉलेज से या फिर टीजी कॉल करेंगे about your attendance. Okay. प्रीलिम एग्जाम भी होगी, उसकी डेट अभी फिक्स नहीं है, whether it is going to be subjective or objective, मतलब डिस्क्रिप्टिव लेनी है या फिर एमसीक्यू बेस लेनी है, वो डिसाइड नहीं है, दैट विल बी डिसाइडेड लेटर ऑन. सो टू समराइज, term end on 11th of November, unit test 2 on 24th October, 31st October, and 1st November, that is on Saturday and Sunday. That will be on unit number 3 and 4. Get your lab manuals ready in printed format or in write-ups and get your journals completed before 11th of November itself. Okay, and your parents will going to have a call regarding the attendance. Okay, so moving on to next numerical, and this is very interesting and very important as well. Okay, because here a new point is mentioned. Okay, one more numerical is there. Let us go through it. So electric field between two concentric cylindrical conductors. So okay, cylindrical capacitors. So 0.1 and 0.5 meter is this radius. Electric field दिया हुआ है, fine. Energy stored in 1 meter length. Find करना है, okay. Assume free space and neglecting fringing losses in the capacitor. तो ये जैसे ही दिया जाता है, neglecting the fringing and the losses in the capacitor, थोड़ा सा length of the numerical बढ़ जाता है and difficulty level भी बढ़ गई ऐसे लगता है. Okay. So let us put down the formulae required to get the unknown quantities. To find the energy stored, okay, ये given data लिखा है. To find the energy stored, we have only one formula, 1/2 CV square. Okay. तो यहाँ पे we need to have a C as well as V. How to get them? So we do have C is equal to 2 pi epsilon 0 L upon ln B of A, B upon A. This is the capacitance of a cylindrical conductor. यहाँ पे B भी दिया हुआ है आपको, A भी दिया हुआ है, and you are also given with L, that is 1 meter length. So सब कुछ तो पता है भाई, C तो कैलकुलेट सीधा सीधा हो जाएगा आपको. Then V is expressed as minus E bar dot DL bar. E bar का expression दिया हुआ है आपके पास. DL bar will be dr AR cap. Step forward cylindrical and spherical, always DL bar will be dr AR cap. Put the values in the integral, so we will have minus 10 raised to 6 upon R dr. So that will be kind of minus 10 raised to 6. यहाँ पे रेडियस रखेंगे. रेडियस कैसे आती है? हमेशा आउटर से इनर में आती है. So ln of A upon B, or we can incorporate this negative sign as 10 raised to 6 ln of B upon A. Opposite कर दिया. So we can calculate the electric field intensity and sorry, we can calculate the voltage. And okay, now we have C as well as we have V. So put the values into the formula and get your energy stored in the cylindrical capacitor. Okay. And now moving on to next numerical. A parallel plate capacitor, this is important and interesting. A parallel plate capacitor with separation दिया हुआ है, okay, D is equal to 1 centimeter. ये कितना दिया हुआ है? D is equal to 1 centimeter. Has 29 kilovolt voltage applied across. तो voltage दिया है 29 kilovolt across the plates. When air was the dielectric used as a dielectric medium, the dielectric strength of the air is, कुछ तो नया word आया, dielectric strength आया है, is something. A thin piece of glass with epsilon r is equal to 6.5 and dielectric strength with 290 kilovolt per centimeter and thickness of 0.2 centimeter is inserted. Find whether glass will break or air. ये बीच में breaking और dielectric strength कहाँ से आ गया? Okay. As actually we already talked about the dielectric strength, but let us revisit. Let us look at the geometry. D is equal to 1 centimeter and it is called as कि भाई एक ग्लास मटेरियल यूज किया गया ऑफ थिकनेस 0.2 और उसको इंसर्ट किया गया. सो वी डू हैव टू कैपेसिटेंसेस कनेक्टेड इन सीरीज C1 एंड C2, जिसमें D is equal to 0.8 for C1 and D is equal to 0.2 for C2, and we will have two capacitances connected in series over here. Okay. And about the dielectric strength, we do have, if electric field produced inside a medium, electric field produced inside a medium is more than dielectric strength, then that medium will break down. मतलब अगर इसकी स्ट्रेंथ है कि भाई मैं ना, एक कैपेसिटर की स्ट्रेंथ है कि भाई, ह्यूमन की छोड़ो, ह्यूमन की कंसिडर करते हैं, ह्यूमन की स्ट्रेंथ है कि भाई मैं ज्यादा से ज्यादा 50 डिग्री सेल्सियस में सर्वाइव कर सकता हूँ, लेकिन मैं कहूँ कि यार नहीं, ये नहीं, आपको ना अभी 80 डिग्री सेल्सियस में रहना है, सो ह्यूमन विल ब्रेक डाउन. Same way in a dielectric material, if its strength is, let us say for an example, 30 kilovolt per centimeter, and the field produced inside the capacitor is, let us say, 32 kilovolt per centimeter. So this produced electric field is more than the strength of the material. So that material will break down. मतलब रेटिंग से ज्यादा अगर वोल्टेज क्रिएट हुआ तो दैट मटेरियल विल ब्रेक डाउन. दिस इज द अंडरस्टैंडिंग. E1, okay, is equal to V1 upon D1 and E2 is equal to V2 upon D2. इलेक्ट्रिक फील्ड ये ऐसे क्यों लिख पाया? क्योंकि इलेक्ट्रिक फील्ड का यूनिट अगर देखते हो तो इट इज वोल्ट पर मीटर. सो वोल्टेज अपॉन डिस्टेंस, वोल्टेज अपॉन डिस्टेंस, दिस इज इंपॉर्टेंट पॉइंट. अगर पता है तो ही कर पाओगे, नहीं तो no ways to solve the numerical. Then we don't know about V1 and V2. We know about the D1 and D2. So voltage across capacitor C1. आपको अगर एक फॉर्मूला याद होगा, पोटेंशियल डिवाइडर अरेंजमेंट, अगर यहाँ पे V है, we have R1 and R2 and this part is connected to ground, we can calculate VO. Okay, VO can be expressed as R2 upon R1 plus R2 into applied voltage. In the same note, similar note, not same, but on the similar note, we can find the voltage across the capacitor C1. क्योंकि यहाँ पे क्या दिया हुआ है आपको? V is applied, you have C1 and you have C2. Okay, this terminal is not connected to ground, but it will be connected to somewhere, and we need to find a potential across, voltage across capacitor C1 alone. Okay, यहाँ पे potential कितना है वो find करना है. So we can express this one as V1 is equal to C2 upon C1 plus C2. Okay, C2 upon C1 plus C2 into applied voltage. So how to get it? So, and voltage across capacitor C2 will be, can I say that voltage across C1 is assumed to be V1 and voltage across C2 will be V2. So total voltage is equal to V1 plus V2. So we can write down V2 is nothing but V minus V1, rearranging the terms. So we will write down, since V is equal to V1 plus V2, V1 somehow we will calculate, we really don't know, but we can put the values, put the values and we can get the answers. Okay, तो ये C1 क्या है? पैरेलल प्लेट कैपेसिटर है. सो C1 का वैल्यू यहाँ पे आया. ये C2 भी पैरेलल प्लेट कैपेसिटर है, तो पुट द वैल्यूज. C2 इज इक्वल टू एप्सिलॉन A अपॉन D. ये पता है, ये पता है, ये पता है कि नहीं है? अच्छा, ये पता नहीं है, एरिया एंड D2. Okay, so now you have to take care of ये जो A है और A है, area, those are going to get cancelled out over here in V1, calculation of V1, because those will be common in the numerator and denominator. So area this term will get vanished and we will have the straight value, a plain value for V1 and therefore a plain value for V2. Okay. So this was the equation number 1 where we didn't know V1 and V2. So we do have equation number 2 where we can find a V1, but still C1 and C2 were unknown. We have the formula for C1 and C2, get it from here and calculate V1. Then we have equation number 3 where V is equal to V1 plus V2. So V2 is equal to V minus V1. V is given as 29 kilovolt in the numerical. From equation number 2 we have value of V1. So now V1 and V2 अपने पास है, D1 and D2 अपने पास है. So you can ये V1 की वैल्यू लीजिए, ये V2 की वैल्यू लीजिए, put it over here V1 and V2 and you will get the E1 and E2. Okay. And at the end of the numerical, I haven't given the so क्या कहते हैं उसको values, but at the end of the numerical, you will have E1 as somewhere 34.95 kilovolt per centimeter and E2 as 5.25 kilovolt per centimeter. E1 is E1 is due to air and E2 is due to glass. Okay, एयर का डाइलेक्ट्रिक स्ट्रेंथ कितना दिया हुआ है 30 किलो वोल्ट पर सेंटीमीटर एंड ग्लास का डाइलेक्ट्रिक स्ट्रेंथ दिया हुआ है 290 किलो वोल्ट पर सेंटीमीटर. ओके, तो E1 कितना है 34 greater than 30. So therefore this C1 is going to get damaged. The capacitance created due to air as a dielectric material. क्योंकि वहां पे फील्ड ज्यादा प्रोड्यूस हुआ, that is more than its strength. So air medium will break. With this say, we will end our today's session and it has been extended 6 minutes by 6 minutes because we started late with 6 minutes or 7 minutes. I don't remember. But this is how your unit number 2, part of unit number 2 is done. And I will take 1 or 2 more minutes, please. Please be with me, please. So electric field in free space conductor dielectrics we have observed. Dielectric polarization we have seen. Dielectric strength we have understood while solving the numerical. Then we have seen the significance of portions and Laplace equation as well as capacitance. This energy density was covered as a part of unit number 1 and its applications, that those are numerical. Then about this much, electric field in multiple dielectrics, that is boundary conditions of dielectric and conductor dielectric, this will be seen in unit number 2. So I can say that at this moment of time, the green underlined wordings will be covered in unit number 2 due to symmetry and easiness. Unit number 2 is completed. Okay, unit number 2 is completed, straightforward. Okay, and let me download the attendance. And अरे download हो नहीं रहा है क्या? Not really sure about it. One moment, please. Let me check. Okay, attendance has been downloaded. Let me stop the recording.